Factoring polynomials. So this weekend I went to a conference on the flipped classroom, doing exactly what we do, watching videos and then coming in and practicing. And the gentleman that spoke said that your lessons shouldn't be more than like 5-10 minutes. And I'm like, holy smokes, how am I going to do that? So he sat and really talked about it, and so it really made a lot of sense. So I'm going to go through here, and we do have 2 lessons to do, so I'm going to try and do this in about 10 minutes, okay? So I'm going to focus in on some vocab words. So factoring expressions is one gateway skill that is necessary for much of what we do in algebra. So factoring is huge. The word factor has 2 meanings, and both are important. So to factor, the verb, is to rewrite as equivalent products. But then factor, the noun, a factor, okay, is an algebraic expression that is one part of a larger factored expression, okay? So to the noun and the verb, all right? So let's take a look at example 1. It says, consider the expression. We've got this binomial here. And we've written it into 2 expressions, and now we're going to factor these. Okay, so essentially it's like we're going to do a factor tree, but we're not going to make it a tree. So we know that 6 is made up of 3 times 2, and x squared is made up of x times x. And 15x is made up of 3 times 5 times x. So now when I sit and think about what they have in common, they share a factor of 3 in common, and they also share 1x in common. So the GCF for this term, for these 2 terms, would be 3x. So now it says, using the distributive property, rewrite this binomial as a product involving the GCF. So, and essentially I'm going to undistribute here. So my GCF is 3x. So think of about what I just said. I'm undistributing, so I'm reversing the distributive property. So 3x times essentially what's left over. Okay, what was left over here? 2x. Okay, that's what was left over. And then what was left over after we took out the GCF of the 15x, and we were left with the plus 5. So I just was able to factor that. Now it says evaluate both that binomial that we started with and the factored expression that we just came up with for when x is equal to 2. So what do we do with this? Take that x equals 2 and substitute it in. Okay. And we should come up with, this is 24 plus 30, which gives us 54. So if we factored correctly, when we substitute the 2 into this expression, we should also come up with 54. So we've got 4 plus 5 is 9, and then 9 times 6, which is out here, is 54. So they are equivalent expressions. Okay, one is in factored form and one is not. So we need to be fluent in this reversing the distributive property. Sometimes you'll hear me say undistribute, which is the same thing as saying factoring. So I'm going to do just a couple of these, and then what I'm going to have you guys do is I'm going to have you come to class with the rest of them filled in, because I want you to do some practicing at home, so therefore you can come to class with some questions. So when I take a look at letter A, if I sit and factor that 12 out into 2 times 2 times 3, okay, and it's prime factorization, I know that x cubed is that, and then 18 is made up of 2 times 3 times 3 times x, and then what do they have in common? They share 1, 2 in common. They also share a 3 in common, and they share an x in common. So that GCF for those 2 is going to be 6x. Okay. So now hopefully you're going to be able to start to recognize what the GCF is without having to write out the prime factorization. So looking at letter C, I've got 21 and 14. Okay, so 7 should come to mind. That is the greatest common factor for those 2. And now I've got to look at my x's individually. So I might want to write out what is x squared. And then this other x over here, well, what do they share in common? They share only one x in common, so that's going to be part of my GCF. And then when I take a look at the y's, I've got y to the 5th and y to the 7th. Well, they're going to share, the maximum amount that they could share in common would be y to the 5th. So that's the GCF for those two terms. Like I said, I want you to be able to go ahead and fill the rest of those in, okay, to come with questions to class. Let's go ahead and flip this over. And now let's actually take a binomial and factor it. So looking at both terms, I know that my GCF is going to be 2x, and then I end up with what's left over, 3x plus 5. And in order to check yourself, because we are undistributed, go through and distribute and just kind of visualize it. Visually check. 2x times 3x is 6x squared, so I know that that's correct. And then 2x times 5 is 10x. So I know that I've factored that correctly. So let's look at letter D. Now I've got a trinomial, so now I've got to look at 3 different terms and what's going to be the GCF here. The GCF for that is just going to be 4. That's the only thing that they could all 3 would share in common. Now do the undistributing. So it's x squared plus 2x plus 6. Again, do that visual distributing to double check to see that it does in fact come out to what the problem looked like before you factored it. Okay. And we're going to take a look at H. So H, I know that they're going to share in common a 2x squared. Remember that x squared is the max they can share in common. Okay, because this x squared only has x squared to share. This has an x to the 4th, but this guy over here doesn't have enough. So the max that they can share in common is x squared. So now what's left over? 4x squared, because 2x squared times 4x squared is going to give me that 8x to the 4th back again. And then now let's think about what's going to hold the place right here. 2x squared times what gives you negative 2x squared? And it's negative 1. So again, these are some more problems that I want you to work through and fill in and be able to come to class with questions on. All right, so again, being able to factor fluently is an absolute essential skill. You will use factoring in all of your math classes. So now we looked at something like this way back in Unit 1 before we even really knew how to factor. We looked for what was in common. So when I look at this group, this product, and I look at that product, what do they share in common? Well, they share an x plus 5 in common. And then what was left over? So read from left to right. So what's left over? We have an x minus 1 plus a 2x minus 3. So x plus 5. Now we can clean up what's inside those brackets there. It's just plus. So that's just combining like terms. X and 2x is 3x. And negative 1 minus 3 is negative 4. Okay, so we just factored something kind of crazy looking down to something pretty simple. And I want you to do B and come in with any questions. So now let's go ahead and move over to lesson 4. Excuse me. So we are factoring based on conjugates. Okay, so we've got a term there that we need to think about. So it says there are a number of different types of factoring techniques. So we just learned our first one, GCF factoring. The second one that we're learning right now is factoring based on conjugates. But each one of them boils down to reversing a product. Okay, we're reversing a product, that's factoring. So we begin by looking at conjugate binomials, or binomials of the form. Here's where we see what they are, a plus b and a minus b. So what's similarities and what's differences between those two binomials? They both have an a, they both have a b, but they're separated by different signs. One's got a plus and one's got a minus. Those two are considered conjugates. Okay, kind of a cool word there. So it says find each of the following products of conjugate pairs. See if you can see a pattern. Okay, we always talk about math having patterns. So in this first one, when I go through and I've got to multiply, so I'm going to double distribute x squared minus 5x plus 5x minus 25. Combining like terms, minus 5x plus 5x, okay, those go to 0. So I'm left with x squared minus 25. So let's look down at D. Double distributing, I'd get x squared minus xy plus xy. We put the x first and not the y because we always think about standard form, and standard form says when you have multiple variables, you put things in alphabetical order. And then this last term is going to be minus y squared. Again, these are like terms. Minus xy plus xy goes to 0. Xy minus, or excuse me, x squared minus y squared. Hopefully, maybe you're starting to see a pattern, potentially. So this last one, 25x squared minus 10xy, whoops, hang on, let's see if I can move that. There we go. Plus 10xy minus 4y squared. Cancel, cancel, because those go to 0, and we're left with 25x squared minus 4y squared. So, in general, what happens when we're multiplying conjugate pairs, here's my conjugate pair, and all of a sudden I'm down to a squared minus b squared. So what I would like you to do is write in your own words what you started to see as a pattern. And maybe you didn't see a pattern right now as we did just A, D, and F. Go through and see what you get for B, C, and E, and then write in your own words what's happening when you multiply conjugate pairs. Okay? And then, once you write that down, I would love for you to try these. So once you see that pattern, I want you to go from the problem to the answer. Okay? They're really, you don't even need to show this in between step. Okay? All right, so let's go ahead and flip that over. And now let's get into the factoring piece of it, okay? Because we were still multiplying. So it says, we now should be able to reverse this multiplication in order to write the expression as the difference of perfect squares. Okay, perfect squares are 1, 4, 9, 16, 25, 36, 49. You get the idea. Those are perfect squares, okay? And the difference means subtraction. So looking at this first one, x squared minus 81, if I were to factor that, where did it come from? What were the two binomials that it came from? Well, it came from x minus 9 and x plus 9. So I paused there for a minute, okay, because I'm hoping I didn't blow anybody's mind by that. So where did D come from? Okay, 4 is a perfect square, so is x squared. 81 is perfect, and so is y squared, and it's separated by a minus sign. Hence the name, difference of perfect squares. So when you see that, how are we going to factor that? Where did that binomial come from? What was the result of multiplication there? Let's undo that. 2x minus 9y and 2x plus 9y. Okay. Do one more. Whoops, I'll set up my two sets of parentheses. 1 minus 2x and 1 plus 2x. Go ahead, by all means. Okay, I want you to come with those other three done with some practice. This right here, exercise 4, this is going to be our warm-up in class. Okay, I'm going to put that up, and that's going to be the warm-up. All right, so we are done, my friends. I want you to be able to go back and work through those problems, fill the rest of the notes in. I want you to write some things down, some questions that you have, some patterns that you saw. Not too bad for 2 lessons for 15 minutes. I'll get better. See you guys.